So here's a little bit about reductions of ketones and aldehydes. So our first method of reduction can be using hydrides. So you probably remember we've covered that we can use lithium aluminum hydride, and sodium borohydride, and they have some differences, but the main thing to keep in mind is they are both adding H minus. So lithium aluminum hydride is a more powerful reducing agent and a bit more difficult to work with and will reduce more things. Sodium borohydride will reduce ketones and aldehydes, but not some of the other carbonyl compounds. So it's more selective. In fact, it will reduce aldehydes even in the presence of ketones because aldehydes are more reactive. Another way to reduce a carbonyl would be with rainy nickel, and that looks like nickel with hydrogen present, so we call that rainy nickel. So both of these, or all three of these hydride reagents or hydrogenation reagents, this one would be catalytic hydrogenation, will take an aldehyde or ketone to an alcohol. So to alcohol. So another way to take that carbonyl down to a reduced state, the carbonyl carbon to a reduced state, will be to deoxygenate. So deoxygenate. So with these methods, we have the ability to remove the oxygen entirely. So these are two methods, the Clemenson and the Wolff-Kishner. So the Clemenson reduction will be an acidic reaction. So you heat your carbonyl with excess amalgamated zinc. So our double bond O in the presence of zinc and mercury, that's amalgamated zinc, and HCl. So it's a fairly aggressive kind of reaction, and that's aqueous HCl, and that will give us our H's in the place of the oxygen entirely. The Wolff-Kishner will also use but a milder acid. So it's a two-step reaction where we use a milder acid and then base conditions. So if these strong acidic conditions can't work for your material, then you can go with stronger base conditions. So we would start with hydrazine, H2N, NH2, and a little bit of acid. So that's, again, the pH about 4.5 because we're forming an imine. And then the second step will be to add KOH and heat it up. So the first one is hot acid, the second one will involve hot base. I think we should take a look at Kishner reaction works. So first of all, we start with our aldehyde or ketone, and we'll add hydrazine, and it might also be N2H4. You could see it both ways. And a little bit of acid, and we'll get our imine. So this is called a hydrazone. Imine. And formation of that imine follows a previous video that I did on imine mechanism. And so what we're going to do is start from that imine and add the base. So this will be the step 2 part of the reaction. So we start with our imine, lone pair, and we add base now, hydroxide. So that hydroxide is going to take a proton, and we'll remove that proton. The electrons swing down onto the nitrogen. We'll get an imine that has a negative charge on the nitrogen out there. So 2 lone pairs, minus. And now that lone pair can actually move in, and it will push electrons down onto the carbon. So let me write the resonance form that produces. C minus, N double bond NH, lone pair. So we have a negative charge in 2 positions. And now we'll use, I'm going to go on to the next page, we're going to use water and steal a proton back. So what that will give us is now we have a H attached to that carbon, nitrogen's still there, double bond to N, H. And again, this was fairly aggressive conditions with hydroxide present, you'll recall. That hydroxide will still take that proton, pushing the electrons onto the nitrogen. So that gives us the new structure where there's a negative charge on the nitrogen yet again. And then those electrons can move into the next door nitrogen, and that will actually release a pair of electrons onto the carbon. So what that formed is the really quite stable N triple bond N, which you also know as nitrogen gas. And then also a carbanion. And that carbanion will again take a proton from water and that will finally leave us with our deoxygenated carbon, formerly the carbonyl, plus hydroxide. So that's our product, our deoxygenated carbonyl. Carbon, because it used to be a carbonyl, but now it's just a carbon. And that is the Wolff-Kishner mechanism. So remember, we started with formation of the imine in mild acid and finished deoxygenating with strong base.